live for some Odinmade Hero, where I follow this guy Casey and try and learn games programming for myself as he writes a game from scratch. I'm cutting some corners and doing things not totally from scratch, but as much as I can bear to stand doing things from scratch. That's what I'm going to do. I wasn't going to stream today, and then yesterday kind of left off on not a great note. I was trying to figure out how to get this data here in our tile map to just neatly get slotted in to a slice, so that I could then access the slice and have bounds checking and all of that. And I just kind of got stuck on that for a while, trying to figure out not just a way to do it, but the right way to do it. And there's really only one way that I've been able to discover that will work, but I feel like I was just kind of jumping ahead a little bit. I was getting ahead of myself and getting ahead of Casey by fixating on that. And then I started working on some stuff down here to start filling in the tile map. Where was that? Down here. And I think I was just a bit hasty here. So I think I want to kind of see where he's going with this before I waste too much more time trying to figure out how to turn this into a slice, all of this data in our tile map. Because what I really think ought to happen, and maybe he does this here in a few minutes anyways, but what I really think ought to happen is that it just becomes one-dimensional, and then that's it. We just have one long list of tile IDs that map to our tile map, and it'll look like this on the screen the way that we render it out, but it's all just one-dimensional, and then we split it up accordingly. Now that is going to mess with actually, with the way this is written out now, that would work fine, I think. Yeah, because we're actually just accessing the tile map tiles in the slice. Well, right now it's a many item pointer or a multi-pointer, but the whole point is that I don't want it to be in a multi-pointer because, and I think I said this a couple times yesterday, it's an icky convention. That's not what I couldn't think of what I really wanted to say in that moment. I was trying to say anti-pattern, like it's an anti-pattern to use these because they don't have bounds checking, and you can write outside of them and then you seg fault or whatever, and now you're trying to chase that down. Not really a problem if you really understand what you're doing, if you have a really good understanding of that much, but at the same time, even though it's not really a problem and it's exactly what Casey does, I want to try and do things the Odin way as much as I can and just get really comfortable with slices, because if you can just have bounds checking because it's a core part of this one feature of the language that is slices, why wouldn't I lean into that as best I can and use it to my advantage? So the other thing that I was thinking about was that I've had a good first week just chopping through this code and having fun with it and listening to the Q&As and just trying to reflect on the relevance to my own experience. And I'm not totally happy with the way things have been getting split up day by day. So I think, what's up, Devil? I think what I'm going to do is actually try and start on a fresh day at the beginning of each stream as much as I can. And then if I can't get through the whole Q&A, then too bad. If I can get through some of the Q&A, then I will. But it just seems like I'd rather be writing as much code as possible on stream, because the Q&As, time is so precious to me now. I can listen to the Q&A and do dishes or change diapers or laundry, any number of chores, but I can't, code and do any of those other things at the same time. So I feel like I'm just going to do the best I can to get through as much of the Q&A in each day as I work through each day. But if I can't get to it on stream, then what I might just do is take some notes, and then if there's anything interesting in a Q&A, then I can kind of reflect on it on the following day. But I'll work through that stuff off stream. But today there's a good chance we'll probably get through all of this Q&A, just because there's only so much coding. There's like 20-ish minutes left of coding. But so I'll dive in here and kind of see where Casey was taking this, because I already noticed one thing that I didn't assign quite right in the tile map, and that is the count of tiles going across and down, the count X and Y. And so, we'll just we'll do that, and then I'll worry about, we'll work through some more of this, and then I'm probably going to hit a place here pretty soon where, maybe not. I don't know. I guess I can just show how quick, or how close rather, I was to figuring this out. Because where I left this off, I took the raw data from the address of our tiles here in our tile map, and I guess I'll back this change out so it's back to being a 2D array. I took that pointer and I cast it to a multi-pointer, and it turns out in order to get a slice off of that, you index multi-pointers the same way you index slices and the same way you index arrays. It's just the result is different. If you index a slice, you're getting at the element, or you're getting a sub-slice essentially. But if you index an array using that slice syntax, then you get a slice, and it's the same thing with the multi-pointer. So all I needed to do to get this to turn into a slice was the tile map count Y, take a slice up to the dimensions of the length of the data. So tile map count Y times X. And what is this complaining about here? Oh yeah, so it's complaining because I'm trying to assign this now to the type that this is, which is a multi-pointer. We turn that to a slice, and now we're good. So this is all I had to do. I was so close at the end of the stream. All I had to do was actually slice into the multi-pointer after the cast. And now I'm not super thrilled with this still, because it means that, we could technically index outside of our tile data after it's turned into a multi-pointer. We're still using a multi-pointer where I just don't want to use one. It is good that I'm getting rid of it inside of the tile map struct, I think, but the fact that I have to convert to one at all, I wonder if there's another way to do it, but there just might not be. And the reason why I was getting so tripped up on this, I think, is that I was obsessing over the fact that you can access a slice that points to some memory, or rather gives you a handle to this memory that you can then index. I was obsessing over the fact that that slice gives you that, and conflating it with the multi-pointer, almost like they're the same thing. It's just the slice gives you bounds checking, and that basically is true. But I was basically trying to do this, which just isn't right, because the slice has some other data about it, like the length, and so you can't just take that raw address, that raw pointer to the tile memory, and just do that. But you can with the multi-item pointer, because that's literally giving you all of these tiles in this 2D array laid out in memory. So it's just, it clicked for me after I thought about it a little bit off stream after I wrapped up yesterday, and I was just like, damn, I was so close. I wish I had just had a little bit more time to keep going. So it is what it is. But now it'll actually compile, and it's not crashing because we know the dimensions of the multi-pointer that we're accessing. So I think that makes it okay. But like, for example, if I just added 1 to the end of this and said, give me the entire dimensions of the tile map plus 1 more, this should crash, and it doesn't. So I don't know what that's about. Maybe if I added 10, I really don't know. Maybe this calculation is actually just wrong. It doesn't seem like it would be to me, because look, we have Y tiles down and X tiles across. If we're trying to slice through the end of it, plus 10 elements, that ought to break things. So maybe my understanding is still incorrect. I'm really not sure. I could try saying, you know, after I assign this, right, if I then wanted to just print out an element that shouldn't be in there. And what did we say the dimensions of it were? It was 9 by 16, which was that like 144? So if we went to 145, and of course I need to re-import this again. That does not fail. Let me get out my trusty calculator here and see. It was 9 by 17, 153. Right? Those are the dimensions, aren't they? Yeah, 17 by 9. So what if we just reached for 165? Okay. Well, it's saying that's out of range. Which makes sense. So what if we went to 155? Because that's, well, actually that's still out of range, isn't it? Nine times 17 is 153. So now I'm all kinds of twisted around. How is it that we're able to access the 155th element in the slice? Oh, that's right. Okay, so because there's 163. Right. Okay. Does it just zero them out? Like I don't... Yeah, so 163 is out of bounds. No, I do not want to close all my stuff. And this would be the last one. That works. It's saying 212 is the value at that element. But what if we go to... What if we print the... What did we say it was? It was 153. Yeah, so there's one there. It's just filling it with whatever. Yeah, so now we just got random memory that we're reading out. So it's not crashing because for whatever reason, when we slice into the length of the tiles plus 10 more elements, 10 more U32s, it's going to the end of the data where tile's at and then going beyond that and just reading in that garbage, which I'm allowed to do. I feel like I shouldn't be allowed to do it because I'm trying to slice into some memory that shouldn't be there. But anyway, I've spent too long thinking about this at this point. Too long belaboring the point to figure out why just trying to make sense of what I can and can't do with a slice. Like, I really would have thought that by trying to index past the end of the actual tile data that we've hard-coded, right, that it would throw an error, but it doesn't. But we know that tile map count y times tile map count x is our dimension. That is the size of our tile map. And so this is okay, but again, spending too long getting fixated on it, because I think that, you know, ultimately we're not going to store maps in the game like this. And Casey might go ahead and make that change here in a second. But this gets us to where we want to go, at least. And then what's kind of nice here is that we actually don't have to use these more C-style for loops, because we can just, instead of trying to iterate over the slice, we can iterate over the tiles, because we still have that 2D tile array. So that works fine. Of course, I need to get rid of the format package again. And at this point, we'll just move on. And I'll have to do more digging into slices. It just seems like this right here. This, I feel like I don't want this to work. But it's just saying, you know, this is a pointer now. We just said there's a multi-pointer there, so go into that memory and just read it in. Maybe it would be a problem if I tried to change it, and it would say, oh no, you can read that memory, but you can't start writing to it. I don't know. Anyway. Hey, Santi. Take another swig of this real quick. And so yeah, let's just see where Casey goes with this. Yeah, one thing that he actually did that I wanted to do was assign these, and I guess this way you can just have those dimensions baked into your tile map struct to use later. And then if we were going to do the same, if we switch over to using this C-style for a loop, we can do that, and we can just say, well, we can still do it like this and make it a range from 0 to the tile map count y. And then we'd still want to pull this out if we did that, but we'll see where he goes with it. Hey, I'm doing my best not to glug here. There's enough glugging going around as it is.
And of course we'll have to cast that because now it's 1D, all right? Because this is a 2D array, and C would complain if we cast it. Well, you know what? I'll show you the error so you can see it. And then
That's right. I got hung up on it because he goes to just assign his 2D array to the pointer and cast it. He goes to do that, and then he decides, no, I'm not going to cast it. I'm just going to show off what the error is going to be. And then I just went off on my own tangent, like, okay, but what about, you know, slices? Slices, man. You can't do that in C. You can't explain that in C.
We've got our counts in here. Let's go ahead and do that. Count and count. And that is really all we have to do. That is it. So if we go down here, and now we want to do our tile map work, we should, and you know what? Let's go ahead and just change all these guys. Tile map, tile map. We'll have to cast that because now it's 1D. Let's go ahead and do that. Count and do all these guys. Tile map, anything else? Tile map, tile map, tile map. That's good. Tile map. Let me see what else we have to do here.
Yeah,
let
done
the
all
compiler
that.
guide you. Well, we're gonna talk about that in a second. There we go. Tile width, tile height, and tiles. Okay. Okay. So I think we're good there.
Yeah, so he seemingly just doesn't bother changing it. He's still working over the actual 2D array to fill in the tile map. So I might just wipe this other code out, because this obviously, doing it this way looks better than doing it this other way that I have commented out. And then I don't even have to bother pulling out the tile from the slice.
There we go. So this is the cast that I want to talk about, right? Basically what I'm saying is that a 2D array, something declared as a 2D array in C cannot be cast as something that's a 1D array. And so we have to tell it that it's okay. We're going to treat that as a 1D array, like it's fine. Don't worry about it. Okay, and so we haven't actually done anything yet, so our code is still running exactly the way it was before, but now we packed the thing in there. So let's go ahead.
So you see what he did there? This is what I was getting
So our code is still running exactly the way it was before, but now we packed it.
This is what I was getting so hung up on at the end of the stream yesterday. He just does this little cast here to a UN32 star, and he's just saying, you know, I know I have this 2D array that's hard-coded as being 2D up there, but I just want to treat it like I have all the memory in one array. And that is effectively what I accomplished. It's the exact same thing as what I did originally here, when I got really close to just getting the slice that I wanted. But then the way that you access it, you just have to make sure that you know your bounds, right, of the data that you're trying to access. And this is like one of the things that a lot of people get hung up on, and why in Odin slices even exist, because if you do not access this memory properly and stay within the bounds of where you should be, you will get garbage or you will get a seg fault. I guess either thing could happen, where you're reading in garbage data that has nothing to do with what you're trying to do because it's outside of the bounds of the memory that you're trying to deal with, or you know, you read some data and you know, the whole program just crashes. And so this is supposed to give you that nice bounds checking. So it says, give me a slice, give me the slice into just that memory that I care about, and then I have the bounds checking, so I know that I'm not going to, if I iterate outside of those bounds, if I access any memory outside of those bounds, then you know, the compiler will tell me, hey, you're doing something you shouldn't be doing here. You're trying to access memory that you can't have. It's just giving you more insight when something goes wrong, and you can easily point the finger at something instead of having to sit there and look at, like, where am I accessing outside of the bounds of the memory that I care about. This, however, is not, even though I'm getting a slice to this memory, it's still tricky because I have to make sure that I'm doing this properly. And like I'm looking at it and I'm like, yeah, these are the correct dimensions, but it's just the fact that I have to go through making it a multi-pointer, and I don't want to have to do that. And it really wouldn't matter if it weren't for the fact that this is a 2D array. There may well be a better way to do this, but I can't, as of right now, see it. But this works, and you know, this code isn't even going to live for very long, so I really shouldn't care so much. But for my own understanding, I have to make sure that I know what's going on here, because this is... It might not come up in exactly the same way. I don't know why, you know, you would do a whole lot, because when you'll see when we go to do the actual game world where it's like in 3D and everything, it's still it's all treated as though it's in one big block of memory, but it's not treated three-dimensionally. So he might collapse that here in a little bit, but we'll see. I don't even know what a slice is after like 3 streams. A slice is simply a window into some memory that you care about. But rather than it just being a raw pointer into that memory that you care about, the slice has some other information associated with it, right? Like if I go into docs here for Odin and I look at slice, well, actually, can I just... Can I just look at the type? If I just go... No, I can't just like go to definition of the type in Odin. The language server will not let me do that. Yeah, so if I go iterating through slice, I just want to look at like what an actual slice type is. because it's pretty straightforward. It has the pointer effectively to the memory that you care about, the slice of memory that you care about, but it also has the number of elements. So it keeps track of that, so that you're not doing operations to memory that exist out of the slice. Because you can just do that with a raw pointer, and the idea is that you shouldn't be allowed to do that with a slice. So it's just a manner of it's a utility for making it more sane to work through a bunch of memory where you've got all this data that you want to iterate through or whatever and do stuff with. It's a way of making it a lot saner to deal with that memory, so that when you hit a bug, hopefully, because you're trying to access some memory that you shouldn't be, that you'll see that much faster, rather than down the line when you haven't touched this piece of code in what could be months or whatever. You might introduce some change into your code base where now you're accessing outside of the bounds of some memory, and if you don't have the slice bounds checking to tell you, oh, you're going outside of the bounds of this memory that you shouldn't be doing, then it'll tell you. I'm doing a terrible job of explaining this, which is unfortunate because I'm getting so hung up on the details here, but I just need to continue to educate myself because it's a very important thing to make sure I understand well, particularly because what we're doing now is still pretty trivial, and as time goes on, I just need to build a very good intuitive understanding of slices so that working with them becomes very easy and natural to me, and I don't just fall back to being like, oh, I can just do it like Casey does and do the raw pointers and the multi pointers and do it that way, just because doing it that way would not be very Odin like, and I want to have those advantages that slices give you. It just means that I need to understand how they work, and I think I've got a decent understanding at this point, decent enough to be able to use it, because I made it this far and I'm using slices everywhere. You can see I've got a slice here of bytes for the frame buffer, right? I've got a slice of sound samples, and I'm reading and writing into that those slices just fine, and I'm allocating and all this stuff, but I can't just be like, oh, it's working. I want to make sure I understand why that's working and why that's helpful to use that. So anyway, moving on.
In there. So let's go ahead and say, all right, let's replace the check we were doing, right, with the new check. So we've got this function here. We've got is tile map point empty. So what we want to do is replace our is valid, that work we were doing for is valid. We want to replace that by just calling the tile map query that we wrote with the new one. So there we go. Oops. We're going to delete all this stuff because this is the same. We don't need it anymore because we just wrote a function to do it. And in fact, we can even just kind of wrap this in there, which just say is tile map point empty, and then if it is, then we'll go ahead and use it. So there we go, and you can see that it works now that we've factored it out, and it works exactly the way that it did. So if we want to now, we can call this on multiple points. We can just start adding points to test.
Cool. Rocking and rolling. So basically, all we've done at this point is get the collision detection working exactly how it was working before, but instead of checking to see whether we're colliding with something that is just one point that is static, we have this reusable proc here, and we can check multiple points, which is what he was just talking about.
Like if we want to, right? We can just say, all right, let's test a bunch of different points. Let's test the new player x minus the player width, right? The half the player width. So that would be, that would be this part, this corner of the player. And let's go ahead and do the other corner as well, right? It's going to be here. Of course, I got to move him out of there first so he doesn't get stuck. That's a good idea. And so we'll test all of those, and we're going to say they all have to be in an empty space in order for this to work, right? And so we just need to move the player width up here. Again, this is sort of, you should feel those tingles. You can see the code start to move into.
Okay, so he's going to move those player dimensions and the player dimensions are going to be moved up there where the tile map is defined or close to it.
It's sort of aggregate.
And he actually did all this stuff before initializing the game state even. Oh yeah, and like above Yeah. So up above here, just trying to keep this at least somewhat organized the same way he has it. He's got the memory initialization way down over here. Player width and height. Where did he pull the game state out? That was actually down where he initializes the memory too. And then I think that's basically it. I put those constants up above with my other constants, and I think we're good.
Which is what we're trying to do here. So there we go. And now, when I move in theory,
and he actually, I don't know if I needed to take that player left and player top.
Here. So there we go.
I didn't know. I don't know if I needed to move those out. In fact, yeah, because this changes after we've calculated the new player X and Y. So that was not correct to point those or to move those out. We want to calculate that after we've done all of this, and then over here, gotta clean this up. If I'm not mistaken, I think that's what he did. So at this point, we're just checking these different points to make sure that no part of our little yellow rectangle, right, will collide, or rather we're making sure every side of it will collide with any of the walls in the tile map.
And now, when I move in theory, you see how I stopped there? I couldn't get in there. Stop again, right? And so now we're sort of abutting against the tile, and we can't go into it, right? So we're starting to get somewhere. We're starting to get somewhere. We've got some information about how we should make things work. We're sort of getting a little closer, right? You would never.
I missed what he did. Oh, should have left that bracket in there. So I missed what he did, but I think this is all he did. Yeah. So you can see now, before I was pushing into the wall a little bit, the little rectangle was, but now we collide with every wall like we should, no matter which side we're hitting it from. And I can walk up to the wall from the bottom, because it's kind of like, it's weird because the perspective in 2D is weird, but like here I'm standing right in front of the wall, right? But I can't go into the side of this other wall. I can't move through it. So cool. I mean, I was within 5 minutes of getting that done. I should have just followed through instead of getting obsessed with, you know, how to turn a 2D array into a slice. But I didn't want to just hand wave it away from myself. I needed to make sure I had a better understanding of what was going on. And now that I know how to turn that multi-pointer into a slice, and I could probably convert it back to whatever else it needed to be, depending on what I needed to do with it, I feel comfortable moving forward after that.
Never want this game to play like this. It feels awful. You get stuck on the sides and all that stuff. So we're real far from a good game. But, you know, hopefully you can see how we're making sort of slow and steady progress towards the design that we want, right? Baby steps, but the steps are easy to do and really easy to understand. And that's what you want to do when you're coding. Baby steps that are concrete and where you have good information about whether your design is going in a good way, a good direction, or a bad direction, right? All right. So now that we've got this, the other thing that I said that I wanted to do, right, is if the player moves off of the tile map, I want them to move into a new tile map, right? So let's think about what has to happen in order for that to occur. Okay. So, in order for that to occur, we know one thing right off the bat, which is this tile map here is not going to be able to be static. We're going to need multiple of them, right? And so, in order to do that, we've already set ourselves up for that a little bit because we've got this tile map here. So I'm going to go ahead and promote that tile map out to the H file so that I can see it and understand it. So there we go, we've got the tile map, and that's all good. But we're going to need more tile maps, right? We're going to need, let's say, at least 4 tile maps so that you can walk around between a couple of these tile maps. So in order to do that, what I'm going to do is I'm going to define more than one of them, right? I'm going to define more than one of these tile maps, exactly how you might think. You know what, let's just do 2, because 2 will be easier for us. All right. So I'm going to have 2 things here. I'm going to have tiles 0, right? And there's, of course, Emacs messing up the indentation. Thank you, Emacs. There we go. And tiles 1. So now I have 2 tile maps, and I'm going to go ahead and make these semi-coherent. So I'm going to basically say, all right, there's no doors on these except for the doors that would actually lead to a valid tile map on the other side. So they're going to be like above and below each other. So you can go out the top of this one because there's 0 there, and you'll come in on the bottom, right? Make sense? Yeah.
Oh joy, more hard coding of tiles. So we'll just say, like he did, this is our tiles 1, this is our tiles 0, and we're closing off all the doors leading outside of the map, except for the bottom on the first one, and then the top on the second one. How did that happen? It's never fun when I just jump to a completely wrong place in my editor that I had no intention of going. I don't even know what key I hit. What? Yeah, tiles is undeclared, so, well, that's fine. We'll fix that.
So, should be good. So basically, I'm just going to define 2 tile maps here. I'm going to define this tile map here, right? And I'm going to define this tile map here. And I'm going to do the shorthand of just cloning.
Right, so he's just going to make a new one out of the existing one. Right, okay. So we'll give that one the first tile map. And actually, I don't need to copy that whole thing, because like you just did, we can just instantiate it off of the first one. But then say that tile map 2, I don't know how to do the variable naming for this. _2, just straight up 2, but then I have, yeah, let's just keep it snake case. Try and keep it kind of consistent. Tile map 2 dot tiles equals tiles 1. I feel like they ought to line up, but I'm just trying to follow Casey. So, and then I have to do the same conversion to a slice that we do with the first tile map. And I have to fix these names. There we go. Okay, 2 tile maps. Let's go. You're a camel case advocate. Honestly, it doesn't matter too much to me. I just like to stick to whatever the conventions are of the language that I'm using. And in Odin, it's snake case for most things, and then something that I've never used before, Ada case. And like this is an example of that. I'm very much used to title case for types, but the Odin compiler uses Ada case. I guess it's more consistent in that, like, you know, your titles have the your types have the title casing, but it's, you know, snake cased, which is like Ada case, right? But then your variables and other such things have snake casing. That's certainly, this is what I've become very used to, just because all the languages that I use snake case for the most part, except for JavaScript. But yeah, it doesn't matter to me. I just like to stick to whatever the language, you know, style guide is, if I can.
This tile map has got the stuff in it that we want, yeah, and then I'll just go ahead and change the tiles pointer here, right? So I'm going to go ahead and say, all right, we've got the tile map 2 tiles pointer is going to point to, you know what, let's also do this. Let's say that we've got 2 of them. Let's just make them an array. So we've got tile map 2, right, brackets 2. So this is tile map 0. It's going to do these things.
Okay, so rather than just have these 2 separate handles, we'll access them off of an array of tile maps. And then we'll say, yeah, tile maps 0. Yeah, that looks a lot better, because I don't like that we're taking our actual tile map that's hard coded in there, and it's indexed 1, and then we're assigning it to 2. That feels nasty. That feels dirty. And then we just assign that to the first one that we built, and we aren't instantiating these anymore, so we just get rid of those colons. Clear out those colons, everybody. Make sure you have a nice cleared colon. And over here, I guess we can just use the first tile map in the tile maps array.
Like that. I'm going to say that tile map 1 equals tiles 1. So there we go. Oop, there we go. 0, tiles map there. UN32. Okay. And I need to clone the other values that are in the tile map here. And that should also tell you something. The fact that I have to clone them is suspicious, right? So keep that in mind. Again, always just kind of look at things and be aware of what is happening and where things are going and how they're doing it. Let's go ahead and compile that. Let's see here. What is... Oh, right. Tile map. All right, so we've already got... So I should call this tile maps. So what we want to do now is we're kind of storing our tile maps. We've got 2 tile maps, one on top of the other. I should probably make them look a bit different. So I'm going to make one of them completely empty and leave the other one basically as it was, right? So this one's going to be completely empty, and the other one is going to be exactly as it was. So there we go. Let's get rid of all of those. We'll get rid of this. There's all of our ones are gone. Okay. So...
I'll go ahead and do that real quick. So the second one is all... oh no. That's weird that I can't block out just the... Like, why doesn't visual block mode give me a substitution on just what I have blocked out? There's probably some key there that some aspect of that command that I can make it, that I can change to make it use the, whoa. Something I can change about that so that I am not doing that. Because did you see what happened there? I just wanted to change everything that I have highlighted here with my visual block selected, but it actually changed the outside 1s to 0s as well. So not a fan of that, but whatever.
What I want to do now is say that I've got these tile maps, and then I'm just going to say that there's a current tile map that is the tile map that we're on, right? And we'll say that it's going to point to tile maps 0 for now. And so everyone who was using tile map dot below me is now going to use tile map arrow, right? It's going to...
Aha, I don't even have to do that because Odin will just implicitly dereference the pointer. So where would I do that? I would do that, yeah, so instead of accessing it here, that does make a lot more sense. We'll just say that our tile map is the reference to the first tile map in tile maps, and that should not be plural. So that looks good. And this should just... I did this again. I did this yesterday. I just wanted to clear it. I don't want to assign it, because what this is doing... What is it complaining about? Cannot assign something to variable tile maps. It's giving me all these other issues. The type of the variable tile maps cannot be inferred as a type. Does not have a default type. Yeah. Type does not have a default type. Well, this will come into play later when I want to define my own vector types, but that is kind of weird to me that I can't just do that and say that, you know, tile maps is a type that is a list of 2 tile maps. Maybe I'm missing something, but I feel like I should be able to do that. It would break everything else underneath that. And we have to change this because those are already pointers, or that is already a pointer. Okay, just gonna back that out a little bit more. I think this is where I had it. I tried to zoom in even further, but it was just too much zoom.
To reference some pointer to a tile map, but it's not really necessarily going to know which tile map it is. And so these are going to work like that, right? And if I recompile this in theory, what is the problem here? There we go. If I recompile this in theory, I should be able to... what are you complaining about? Oh, right. So this guy also needs to access a tile. So this is another thing that we might want to think of. So we already have the code for accessing a tile, right? We wrote it up here. It's this thing, right? So we may want to also pull that out, which is basically get tile value, right? So we can pass in a tile map and the sort of int32 tile x, int32 tile y, right? what we may want to do is just say, all right, let's go ahead and pass it in there, and let's call that direct, so, or unchecked, so that we know that we're assuming that we've already done a check on it to see that it was valid before we actually did it. So we're going to do something that does this, right? There's our tile Y, there's our tile X, and this could be an inline function because it's nice and tiny.
So it looks like he is going to switch this to use this approach here. You know, instead of iterating over each of the tile maps, well, yeah, because he's iterating over whatever the current tile map is. So this, I wonder if I could cast it back, convert it back to the 2D array, and then I could have this neat for loop logic that just works out. But I can investigate that later and not get bogged down, because I just want to wrap this day up at this point. So he's going to turn that access right here into its own proc. I don't know if this is something that I would do myself or not, but in the spirit of keeping things closer to how he does them, I'll go ahead and pull that out. Because, I mean, it'd be one thing if it wasn't such a verbose name. I would probably just say something like get tile. I don't know that I would put unchecked in there, because we're kind of like, we could implement this check differently by saying, does this value, does the index of the tile we're trying to pull out fall within the bounds of tiles? And then you wouldn't have to do any of this, right? I think so. Because that's all, that's what the benefit of using a slice gives us, is that we know its length. And so we know, well, we'd want to know if the index we're trying to get at, if the tile index we're trying to get at is greater than 0 or less than the bounds of tiles. So it would simplify the check just a little bit. I don't know, I'm getting, it's different this time because I'm like thinking through like the mechanics of what's going on building this tile map, whereas before I would have just been struggling to keep up with him. Not that I'm not still struggling a little bit because he's moving at 1.5 times speed, but anyway. So we're going to return that tile map value, and it is, what was it, just an int to U32. That's right, because our tile maps are made of U32s. You cannot use a return statement in the, well, it helps if you actually say that this is a procedure. I don't know what that was, why I was trying to declare that way. And then instead of having these player prefixes on the tiles, we just do that. And that looks good.
We're just going to return that tile map value. Right? So now we have a way to query in, and we don't have to know about this code anymore. We can just pass in a thing where we actually ask for our player tile X and our player tile Y in a convenient way, and we can get it out. So we just pulled that out there, right? Let's see here.
And I do get why he's doing it. He wants an easy way to just say get tile instead of having to do this indexing stuff. But when I start, if I do that without having a really good understanding of like what this is actually doing, you know, we're getting the index of the tile that we care about that's in memory, in this contiguous chunk of memory. I'm overthinking it a little bit, I think. So anyway, get tile value unchecked, and pass in the tile map, the player tile X, and the player tile Y. And think that's that. Although I still got this problem down here. Yeah, so now I gotta go and change this. Because tiles is not declared. It's in that... Well, I could just do it like this, but the problem is... Yeah, we need to access it off of the tile value. We need to access the right tile value. We need to access the right tile value off of the correct tile map, because now we're dealing with multiple tile maps. Right, so... I'll just comment these out for now. And then instead of doing this, right, we can get tile value unchecked off of the current tile map. And then, what is it, the column and then the row? Because it's X first and then Y. I think that'll just work fine. Yeah. So now we're back exploring our wondrous tile map. And he's probably about to test this himself, but if I try going off the screen here, looks like it's colliding. But we haven't implemented anything to prevent that, I guess. We're about to implement that, I'm sure. I'm sure that's coming up next. Okay, moving on.
So now this guy can use the same thing, get tile map value unchecked, and it can go ahead and ask for the column and the row, and it will do that access right there. So we still are running exactly as we would expect to run. It's all good, except now you'll notice our doors are gone, except for the bottom door, which is good. So all we need to do now is make it so that when we come out here, when we walk out of here, we will be able to leave and move on to the next screen. Right?
Yeah, see that?
So what we need to think
did the same thing as me.
Is the fact that these tile maps are sort of, we kind of want to think about the tile maps as having, you know, continuity, so that almost as if it's one big tile map. But we probably don't want to make it just one big tile map. And the reason for that is we would waste a ton of space in the cases where the tile maps are not dense. And let me go ahead and show you what I mean by that. So one way to do this, that would be pretty easy, right, is to say, all right, essentially what we have when we have all of these tile maps, right, is we, you know, like we've got these two tile maps, they're stacked on top of each other like this, right? And I don't know, I've got some, I've got it looking kind of like this. I've got this put in there. There's a barrier here, but there's a door there that you can go through, right? Looks like that. So one way to do this, right, would be to make the whole thing, this whole thing could be one tile map, right? And we're just viewing a subsection of the tile map. We could do that. The problem with that is what happens when things get absolutely massive. Like, let's say that we end up with a fully 3D sort of structure for these tile maps, where we've basically got, you know, imagine each of these is a tile map, and then there's tile maps on top of tile maps, right? There's like, you go up a level, and there's tile maps here, and there's tile maps there. This thing goes on extremely far. There's like 400 tile maps in this direction, right? And then there's a 300 tile maps in this direction. But they're very sparse. Like, we don't fill them all in. Like, there's no tile maps in here. Most of the levels are not, you know, maybe there's 20 tile maps that go up. There's like ladders that go up and up and up on one spot of the map, but, you know, we don't actually have that anywhere else. So they're going to be very sparse, and it could be very sprawling and sparse. And so what you don't want to do is you don't want to store everything as a giant 3D voxel, basically kind of a thing, where the entire map for the whole world is stored in some giant array. Because, as we've seen, how much space does it take to store something? Well, a linear thing, right, something that's just things along a line, right, is just however long the line is, right? If the line is n long, then it's going to be n space to fill it. So if we have to store, you know, I don't know, let's say we store 1,000 tiles in a line, then we basically have 1,000 times the size of a tile. However big, however much we need to store in a tile, that's how big it would be, right? And you can pretty much see that when you have something like this, even if this was like, you know, 10,000 or something, I mean, how many are really going to go across? This never is going to get to a particularly big value. Even if tiles were, you know, a megabyte or something, well, a megabyte's a little bit large. Let's say they were a kilobyte, 1K per tile, right? Then really all we have here is we've got a 10 megabyte set to store that whole thing, right? So it's just not that big, right? It's not a big deal. But as soon as you start adding more dimensions in there, as soon as you add another dimension, where you're going to do 2 dimensions here, right? If you have another 10,000, it becomes 10,000 squared, right? It's 10,000 times 10,000 to store it, because for every 10,000 of these you have, you've got 10,000 rows now. So you've got like 10,000 rows of 10,000 entries. And these numbers get big really fast, right? In so much as you cannot make a line get that big, you can make a square get big really quickly in terms of how many interior tiles it has. And if we go one further and go to cubed, right? So now we've got, essentially we're storing a 3D world, right? Where we've got, you know, you can go up ladders and down ladders, right? So you can move up tile maps and down tile maps. Storing that is now cubed in however large you want the world to be in any given direction, right? So again, since we only want to be able to store stuff where stuff actually exists in the world. If there's a tower in the world and you can go up 20 flights in it, we want to only have to store the 20 flights. We don't want to have to store 20 flights virtually for every square on the map, for every tile map for every section of the tile map on the world, because there might be nothing there. So you're just storing empty air. So essentially what we want to do is we want to be able to say we only have tile maps. We only have a 2D tile map section where one actually exists in the world, so that we can feel free to have long, windy things and tall things in places where we want them without paying the cost of that everywhere and making it prohibitive, right? And so, that's just prevents you from having to pack your world so that everything is densely packed in one area. You can make like kind of large sprawling things and still take up the same amount of memory. And that's called sparse storage. Sparse is the word we use for that, because you can say that something is dense, which means that like all the entries are there, or you can say that something is sparse, which is that you have a storage scheme that doesn't cost much to store nothingness, right? So what we're looking for is something sparse that lets us store tile map sections only where the player can actually walk to, and not waste a bunch of memory storing them where they're not. And so again, that's why I can't just make a giant 2D tile map of the entire overworld, because I may want to have long, thin things extending out through parts of the world, and if we were to actually try to store tiles for the entire world as if it was a giant filled-in 2D grid, we would blow out memory too quickly or something like that, right? Okay, so we want some kind of sparse storage for this thing. So what I want to do is basically say, okay, I would like my tile map queries, I'd like to be able to still do a query as if I was querying stuff sort of uniformly, but I would like to basically say, is it okay for the player to move outside of this door, right? Can he move down? What's down here, right? I want to be able to know the answer to that question. And so in order to know the answer to that question, what that means is that going off the edge of one tile map should bring me onto the next tile map. And we only have 10 minutes here, which is a little tight. So I'm wondering if I would like to start this.
I keep distracting myself thinking of ways to do this differently, and what I can do is like take a slice of tile map.tiles, right? Take a slice of the slice up to the length of a row. Whoops. Yeah, up to the length of a row. Or would it be... Yeah, no, because we're jumping that far ahead, up to the length of a row, and then do the same thing. Yeah, I think there'll be a way to do this that, not that this is terrible, because this is basically exactly the way Casey's doing it. In fact, he's probably doing it more like this off of the actual tile map members instead of those constants. But I'm gonna play around with this later and see if I can pretty this up, just because I'm looking for ways, how do I make this even neater using what Odin gives me? That's all.
I would like to start this, but I don't know if I have time. We'll see what we can do. So what I want to do here, right? We can sort of see what happens. What I want to say here is, okay, so you can see this is tile map point empty thing. It's only got one tile map, right? And so it wouldn't be able to look at a different tile map. So what I kind of need to do is I need to be able to do that in a way that asks about more than one tile map, right? I need to be able to ask about this in a way that's more than one tile map. So you can already see, I already have a hint, which is I know I want to be able to do these point queries easily. So I basically want a function that works exactly like, oops, let's not move that, that works exactly like this. But I don't actually want it to only access one tile map at a time. I want it to access the whole world's worth of tile maps, right? So if you imagine what this would look like in a thing that says, if I clone this function basically, and I say something like, is world point empty, right? And I want to be able to pass this sort of a test x and a test y, and I want to be able to know, essentially what's going to happen to the point, considering the whole universe of tile maps that we may have defined, right? What I need to do is figure out a way to sort of get it so that the coordinates of this thing, we can even, we can look at it directly in here, right? Just imagine cloning this function. When we come in here and we use the test x and the test y, they are relative to some tile map, right? They're relative to some tile map in the world of tile maps. But if I go off that tile map, I would be relative to some other tile map. So what I want to do is, instead of only considering the case, so empty was set to false, instead of just assuming that a tile is not empty, that a tile is like filled, which is what we're doing, if it does not exist inside this tile map, what I want to do is use these cases more intelligently to figure out what tile map I would be in, right? And ask that tile map. Does that make sense? So what we need to do is introduce a higher level of coordinate here. We need to introduce sort of where we are in tile map space, right? And so what you can see is I've started to do that here. I said we've got 2 tile maps. We've got tile map 0 and tile map 1. So you can imagine saying we have some index that's where in tile map space we actually were, right? So instead of passing this in a tile map, what we need to do is pass in, like, you know, basically the world map, let's say, world map, or just world, let's call it just world. We're going to pass in the world here, and we're going to pass in some kind of notion of which tile map X and Y we are on. Now, at the minute, and you know what, I probably should, just to show the full thing here, I probably should go ahead and say that we actually have 4 tile maps, right? Because that way I can show an X and a Y happening. Okay. So, well, you know what I'm saying, this kind of thing, right? Does that make sense? Yeah, okay. So let's say I go ahead and blow that
No!
out, and these are all...
Not more 2D arrays. It's fine. It's fine.
Empty again, so I've got tile maps 2 and 3. Okay, and so let's pretend that we've got this guy here, and this is...
Okay, yeah, now I gotta go and copy all of those. Well, such is life. So let's go down to here, and we'll get 2 more of those. Did I do that right? What did I even do just there? I thought I was pasting, but I was jumping around. So this will be tile map 2, and this will be tile map 3.
This is tile 0, 0, and this is going...
Yes, because now we have to account for the fact that we are in a 2D tile map array. And then what is this, 0, 1?
To be, so that's like, I'm gonna say that's X and Y basically. So basically we've got tiles X and Y, so this would be right below this guy. And so then both of these guys will be able to exit off the side, like this. And these guys will be coming in on the side, like that. So now we've got tiles 1, 0 and 1, 1. And so that, again, 1, 0 would be on the top, so it would be that way, and the other one would be on the bottom. So it looks...
So how did he lay this out? He took the first one and made the door at the bottom. Yeah, so we got doors open on the bottom and to the right. And then for this one, we've got a door open on the top and to the right. And then over here, we got a door open to the left and the bottom. Yep. Is that the middle? Yeah. And then this last one, we have a door open on the top and to the left.
Like that. No, that's a mistake. Why did I do that? Should be, oops, should be there. Shouldn't it? Yes. Yes. Oh, no, I'm right. Never mind. Getting confused by my own scheme. So I'm just kind of making this by hand here. There you go. And so, you know, these guys will be in that pattern. And so now I've got my tile maps here, and I'm going to go ahead and lay them out manually, again, just because we're not at the point yet where I really know what I want from everything. So we can go ahead and do this for all of these, right? So we have our tiles. We've got our, excuse me, our mother tile, essentially, which so we're going to go ahead and clone that tile map so that everyone has
the
their
mother tile. Praise the mother tile, from which all other tiles are born. So... oh God. So yeah, so for this first one, you gotta do it. You gotta access the tile map that's within the first row of tile maps, right? And then we set it up to have all these dimensions, and we say these are all the tiles. And then for this one, well, for the rest of these, yeah, we'll just say for this one, we're getting to the top left, or rather top right tile map. This is wrong because you're looking at me, right? So over here, our first tile map is 0, 0, 0, 1, 1, 0, 1, 1. Yeah, I think that's right. And then we're going to just take that off of the first tile map. We're going to start off in the first tile map that we find at the first index of the first row of tile maps. And then this is going to be 0, 0, This is going to be 0, 1. I think this is kind of messed up just because of the... Yeah, because we're going to be going down. Right? Down rows. So this might actually be reversed, but we'll see when we get there. So yeah, so then we're going to duplicate this here. And we're going to just do that like so. This will be 1, 1. Just like that. So that's what these naming conventions are about. You know, we define each tile map according to the index that it exists in, or that it should exist in within our 2D tile map array, which comprises our game world, right?
And we haven't quite finished pulling all the stuff out that we want to, but we're going to go ahead and just do the basics here. So this is 0, 0, 1, 0, 1, 1, like that. And we're just going to initialize them exactly to what we just labeled them as in the other thing. So you can see, there we go. Oops, got to finish the world stuff first. Skip over that. Skip over that. I don't care about any of this. Okay, there we go. And there we go. All right. So we've got a bunch of work to do here, right? And this is why I said I didn't know if I want to start this yet, because we may leave things in a broken state today, which would be unfortunate, but sometimes we got to do that. Basically, what we need to do now is we need to sort of have something that contains all of our tile maps, right? And so I'm just going to say that we've got that world struct, right? We've got that world struct, and we don't really know what it contains yet, but we know at the very least it's got to contain these tile maps, right? It's got to contain all these tile maps. So basically, we've got the tile maps here. And we have to sort of have that pointer, and the only thing we know so far is that we're going to have to store all these tile maps, and we're going to have them in something like this world struct, so that I can pass them around to things that need to be able to work with them. So we've got tile maps, and the tile maps are going to equal a pointer to our tile map struct, right? So there we go. So inside the world here, now we sort of have something where we're going to go, all right, we have a tile map X and a tile map Y that we're going to use as coordinates to look up into this thing. So we're going to have to use the exact same map that we just did.
Yeah, so at one point I was like, I don't think we're going to have to use this that often, where we're but we're converting a 2D array over to a slice, and we're going to have to do it again here. We want a slice of tile maps from our 2D tile map array. I think I felt that coming in my bones once I saw that he was going to make it two-dimensional. So yeah, that's fine. We'll just go with it.
This kind of a strided lookup in sort of this get tile value unchecked, right? And that is something that we're going to want to do again. We're just going to clone that function for getting the tile map out of the world, right? So we have a world structure, and we're going to have a tile map X and a tile map Y that we are going to use to pull out the world coordinate. So
right. So get tile value unchecked, doing the same thing, but as far as the whole entire world goes, we want the right tile map out of that entire game world that we're building here. And tile map X, tile map Y. Get tile maps off of the world, and it'll work just like this. And we want to return, a tile map. I think that works.
Again, we know exactly what this looks like, right? We're going to have a thing where we essentially have a count X and a count Y, and we're going to look up a tile map in here. Now, what we said, we've got a problem. You know, like I said, this is still going to be dense so far, but we'll kind of, yeah. I'm running out of time on the stream is basically what it boils down to. I won't be able to get to the sparseness, so we'll just drop a thing in here to do beginner's sparseness, basically, which we have to do. Okay, so basically what I want to do here is I want to be able to say, all right, get me the tile map that goes with some coordinates for the tile map. And all that's going to do is exactly the same math we did before. It's going to look up into the tile maps using the tile map Y and the tile map X, and it's going to use essentially counts that we put in there that says how many across each one is, right? So we've basically got a tile map count X and a tile map count Y, and that'll go ahead and look up an actual tile map like this, right? And we will return that tile map like that. And now what we probably want to do is make sure that is guarded itself, so we'll look to see whether the tile map X and tile map Y are in bounds, again using the exact same math that we were using before. Nothing out of the ordinary going on here, like that, the world, and we go, set tile map. Oops.
So I think it's important still to store those values, right? Of course, I mean, you want to know what the dimensions of your world are, but I think we can just neatly say, you know, if tile map, well, let's say tile map index equals tile map x times the world count. Is this right? Yeah. Times the width of our world and tile maps plus the tile map x we're trying to get to. This is our tile map index. And if that index is greater than 0 and it's less than the length of the world's slice of tile maps, this does the same thing, but it's a slightly neater check. So I think this confirms for me, because I'm seeing that I can do it in 2 places here. This confirms for me that this was a good idea to do this way. So I'm gonna make that change for getting the actual tile inside of the tile map as well. And what is going on here? Oh, I didn't even bother. Not only, yeah, so tile map index is less than, yeah, no, that's right. We want it to be less than the length of that slice. And then we are not instantiating this here. We are assigning it to our 0 to tile map that we assign up there. And that looks good.
Like that. And same thing for y. So there's our y's, right? There we go. So we've got our get tile map function, and what that can do is that'll now give us a tile map. Right? There's our world point.
Doesn't this current implementation still have that issue about blank areas in the world still taking space? It would, but that's why he left that to do in there, right? This do up here. Whenever he writes in a to do, I do the same thing as a note to myself as well. Right, so he realizes, you know, there's not enough time, and, you know, as it happens, I also don't have much time either. I thought that I would get through some of the Q&A this stream, but just goes to show I spent too long obsessing about slices. But I think we're going to get to a point where, like, we can just use this world that we've created, but then the sparseness we won't start implementing that until the next day. So probably Monday before we get around to that.
There we go. That'll give us a tile map. By saying whatever the tile x and y that we had there. There we go. Get tile map.
So we're in is world point empty, and we want to call get tile map off of or with the world, and okay. Yeah. So the tile coordinates are test x and test y still, but tile map x and tile map y are going to be ints, which go over here, because this gives us the index into the world tile map that we want, and we're passing in tile map x and y. That is the right order, right? And here is where we get our tile map. And then everything else kind of stays the same, except we're gonna, right? Isn't everything else gonna stay the same? Cannot assign, what is that saying? Cannot assign value of tile map to pointer. Okay, so we're gonna have to pass that in by reference.
Whatever that tile x and y that we get passed in, we're going to look up what the map is that corresponds to that tile map x and y, right? We're going to say if that tile map...
Does get tile map, did he return? He returned a reference to that tile map, not... Yeah, okay. Something was not adding up there. So this needs to be a pointer, because otherwise we're just changing a tile map that we've pulled out. Like this, if we don't make this a pointer, then the changes that we're making, well, we're not making changes to the tile map. I don't know. I know I know I'm going to be in trouble if I don't make this a pointer. That could definitely lead to trouble down the road. Okay, so now I don't need to pass that by reference to get the tile value unchecked. We're good.
Tile X and Y that we had there. There we go, get tile map. Whatever that tile X and Y that we get passed in, we're going to look up what the map is that corresponds to that tile map X and Y, right? We're going to say, if that tile map is valid, if there was actually tile map at that location, then we're going to do this thing in that tile map, right? Now, there's a bunch of stuff that, like I said, we're out of time on the stream. There's a bunch of stuff we still have to fix, which is unfortunate. But I'm just going to get this back to compiling, and then we will start the Q&A. And tomorrow we will finish talking about all the stuff we need to do to make this actually work properly. Okay, so
right, because we can't even do this check. We can't even say, is this tile map nil? By making this a pointer, that alone right there, right, explains that. Because if we zeroed it out, we'd be checking, we'd have a tile map object back from this call, but we actually want to get nil back if the tile map doesn't exist at those coordinates. So that's definitely, yeah.
What did I forget to do? Tile map count X, tile map count Y, tile map count X, tile map count Y. What is it complaining about? Not a member. Oh yes, this is actually the world pointer there. Cannot convert to between.
So he's just kind of going through compiler errors and what is going on here? Oh, I didn't have a comma. Was that it? He's just going through his compiler errors and making sure that he can get it to recompile, because he doesn't even quite get it to the point where he can use the new world struct that we've built here. Or maybe he did instantiate it down here and I missed it, but I think this is pretty much where we're going to wrap up.
Oh yeah, this is totally that's just copy pasta, as people say, which is hard for me to deal with when I'm talking on the stream. It's hard for me to concentrate on making sure that I do my basic substitutions correctly, which is unfortunate. All right, so we return the tile map, and this thing needs to return a tile map pointer, right? There we go. Okay, so where are we at here? We're still running properly. Okay, so I want to start the Q&A, but I'm just going to briefly say where we ended up, and then tomorrow I'll recap it. So basically, all we're trying to do here is extend our notion of tile maps out to having multiple tile maps, right?
Yeah, so he did actually instantiate the world down there, which I did not catch. So right over here, rather than getting our tile map off of the tile maps that we've hard-coded, that 2D array, we'll get it out of the world, but we'll do that and start messing with it tomorrow. Not tomorrow, but Monday for me. So we want to say that we have our game world here, and we're gonna say that the world's collection of tile maps is equivalent to tile maps. But we have to do the same thing here that I had to do with the tiles, right? We're just going one level up to the game world. So over here, to get a slice from tile maps, I have to do this and cast it to a multi-pointer of tile maps. But we want it to be, 4. It's going to be, we're going to get a slice 4 elements deep to get the whole list of tile maps. And this should be like, he's not assigning it here, right? But I might as well say that the world tile map count X is 2. And the Y is 2. So that way we're actually indexing the slice according to the world's tile map dimensions. Count Y. I think that's good. I think that's pretty much where he's at, and I'm comfortable with that. I'll work through the Q&A on my own time and then be back on Monday to start the next day. But I'll let him finish this explanation before I wrap up the stream, because that was just a lot of stuff crammed in there. You had an ad and you missed the to-do, I see. It's pretty close to Pac-Man, yeah. Yeah, very simple and rudimentary here at first, but it'll get more and more fun and interesting as time goes on. Hey, Nutella, thanks for dropping by.
And so right now we're still doing everything as if we're just on this one tile map, but what we want to do is be able to move between tile maps, so we introduced a second layer of coordinates. That's our tile map x and y, and that's going to tell us where in the tile maps we are so we can pull out the right tile map. Now you'll notice there's some odd things here, right? Like we've still got upper left and up. This is like a rendering coordinate really, and some stuff that doesn't really make sense for the circumstance. And so we definitely want to kind of start looking at these and seeing if these really should be in here, or if these should be in the world and stuff like that. And we also have some stuff to think about in terms of what those mean versus pixels. So we've got a lot of stuff to work out here. So I'm not going to try and explain any more of that because we need all day, I think, tomorrow to explain all what's going on there and move on. But for now, let's end with that because we're, like I said, we're still in a good working state. I think even if we restart from the beginning, we're in a good working state. And so that's a fine way to leave it. And then tomorrow we will concentrate on being able to move between our tile maps, which will be a great place to end the week actually, because then we've got a guy moving around a little world, and that sort of clears the way for starting to get into more bigger and badder stuff. All right. Let's start the Q&A, basically. I think now would be a good time to start the Q&A. So let me go ahead and go in and put the filter on. So please put Q:.
So, like I said, would have liked to have gotten to the Q&A, but I'm going to change this a little bit so that we are, I'm doing the Q&As off stream. If I get to them, I get to them, but I want to focus on programming when I'm on stream because that's some time I've allotted to myself to program, whereas I can listen to him answer questions. And sometimes I like to provide my little commentary to the questions he's answering, but it might get to a point where it's just redundant rants coming from me all the time. Whereas the programming is ideally, it's always going to be something new and interesting and different that we haven't looked at before, because he's always going on to building different features that we haven't looked at before. But quite a bit of code added. We have a 2D tile map array that makes up our game world, and things are coming together. But I'm going to play around with some stuff here. I'll probably do some polish, like I said, and work through the Q&A on my own. But that's it. Until Monday.